Alright, so today we're going to talk about first order equations, but I want to start from what we understand. I want to start from evaluation of expressions, and something we've done. So if we take a look here, I'm going to grab a marker, and I have to look away from the camera here. We have an expression here, and I say, hey, let's make x 4. Whoops. Now x is 4, so obviously we plug 4 in, we use parentheses, and we get a value of 7. Well, okay, so that expression is 7. Well, the question becomes, how do we figure it backwards? What if I tell you I want the expression to be 7? Well, that means the expression x plus 3 equals 7, shown here. So what plus 3 gives 7? Well, we know the answer is 4. We already figured out the answer is 4. But we do that by balancing both sides of the equation. By taking away 3 from both sides, I don't change either side. So I get -3, -3, and I get x equals 4. And that works for any value, because if we think about it, pick a value, say 7. We know 7 is equal to 7. Well, if I minus 1 to both sides, what do I get? Well, I get 6 equals 6. What if I add 3 to both sides? I get 9 equals 9. Ooh, bad 9, but we'll live with it. The point is, this is true, this is true, and this is true. I'm always allowed to add to both sides of an equation. So let's take a look at this equation. Now it's an equation because there's an equal sign right here. And I want to know what value plus 7 will give me -11. And again, guessing and checking will work, but we want a balanced equation. So I will subtract 7 on both sides of the equal sign so the equation stays balanced. When I take away 7, I can write the expression x plus 7 minus 7 right here. On the other side, I got -11 minus 7. Well, again, we can simplify this. These go to 0, and 0 plus x is still x. And -11, -7, both left is -18. So how guessing and checking works great until you get this problem. Fractions, our favorite thing. So again, I'm going to work through the process here. First thing I'm going to do is make it mixed numbers, all right? Or get from mixed numbers to improper. I do not care for mixed numbers. So here's an improper fraction. And I see that I have a positive 1/3. Well, what gets rid of positive 1/3? Negative 1/3. And I have to do it to both sides of the equation again so that it stays the same. And when I do that, on the left side, I just get x. On the right side, I get 15/8 minus 1/3. And again, find a common denominator, and then you're going to find that the value here is 37/24. 3 and 3, 8 and 8, and make equivalent fractions. These are equivalent. This is equivalent. And once you have equal pieces, 45 minus 8 is 37/24. Now this is another example. X minus 6 equals -8. So something take away 6 is a -8. Well, again, how do you get rid of -6? Opposite operations if you're not seeing it yet. I need to add 6 to both sides. And instead of writing x minus 6 plus 6, these actually just cancel and give you x. On the other side, you got -8 to the left, positive 6 to the right, so you end up at -2. Now again, a lot of this is practice. So this is a good point in the video, so you pause the video. And I'm just going to pull these up every 10 seconds after this. Each of these problems can be figured by using opposite operations. I'm going to start in quadrant 1, then I'm going to go to quadrant 2, then to 3, then to 4. Quadrant 1's answer is 11/6. Quadrant 2's answer is -5. Quadrant 3's answer is 23/15, or I suppose you could write that as 1 8/15. Quadrant 4 gets missed a lot. A lot of people get 0, but it's actually 8. First order equations are called first order because the exponent on x is 1. And again, this is a fairly simple type of problem to get us started.